Good afternoon. Myself Ahana Guchait and Assistant Professor of ID Department. So in today's lecture, I am going to give my lecture on combinational circuit. So combination circuit, it mainly the output variables depends on the input variables. So in combination circuit, mainly the output variables, I am giving the three outputs, okay, or n number of outputs. So we are getting n number of inputs. So we are giving n number of inputs and we are getting the m number of outputs. So it doesn't need any type of memory. So here I have given the explanation. Output depends on the combination of input variables. Next, it does not use any memory. Next, it can have n number of inputs and m number of outputs. Here it is a combination circuit. Here we are giving n number of inputs and getting m number of outputs. That is A, B, C up to, we can take up to n, and we are getting A dash, B dash, C dash and up to m. Okay. Next, there is classification of combination circuit. Combination circuit, that is arithmetic and logical circuit. Here then data transmission circuits and code converters. In arithmetic and logic circuits, there are of three types, that is adder, subtractor, comparators, PLDS. And data transmission circuit, we have MUX means multiplexer, DMUX means demultiplexer, encoder and decoder. In code converters, we have binary code decimal, that is BCD of 7 segments. Now in previous case I have already told you that the adder is mainly the arithmetic combination circuit. As we all know that adder means addition of a bit or a digit. So in case of half adder, adders are of two types, that is half adder and full adder. In case of half adder, we are getting that it is mainly an arithmetic combination circuit that performs the addition of two single bit digits. So half adder, here it is a combinational logic circuit that performs the addition of two single bit. Half adder mainly gives the two inputs and we are getting two outputs. The inputs are called the augment or added bits and the output are called the sum and carry. Here we are giving the inputs. In case of, this is in half adder circuit, we are giving the inputs A, B and we are getting the outputs as sum and carry. This is a truth table of half adder. In half adder, it is mainly the two single bit digits. So 2 means we are getting the 4 possibilities, that is 0, 0, 0, 1, 1, 0 and 1, 1. In case of sum and carry, we are getting 0, 0 means we are getting 0 and means the sum is 0 and carry is also 0. In case of 0, 1, we are getting the sum as 1 and carry, there is no carry. In case of 1, 0, we are getting the sum as 1 and the carry as 0 because there is no carry in case of sum. And 1, 1, in case of 1 plus 1, it is giving the answer 2 and the binary form of 2 is 1, 0. So we are giving the carry as 1 and the sum as 0. So I have drawn the key map for the sum and carry. Here in case of sum, there is in output sum. In case of sum, there is in place of 2 we are getting 1 and in place of 3 we are getting 1. So we will place the higher part, that is 2 ones in 2 and 3. In case of sum, we are getting giving this is 0, 1, 2 and 3. So this is 0, 1, 2 and 3. So we are giving in place of 1 we are writing 1 and in place of 2 we are giving 1. Okay. So now we are getting the result, that is 0, 1 and 0, 1. in case of that, these ones are in diagonally method. These ones are arranged in diagonal method. So we are getting the sum, the output as a dash b and plus a dash b plus a b dash. We are getting this value a dash b plus a b dash. So a dash b plus a b dash is equal to a XOR b. Now in case of carry, we are giving that we are getting, in case of carry we are getting 1 in place of 0, 1, 2, 3, 3 in place of 3. So we are giving 1 in place of 3. So we are getting carry as a and b. Now I have drawn the logic circuit for in case of a XOR b, that is a XOR b, we are getting the sum, and carry, we are from a we are giving 1 and from b we are giving, and by means of AND gate we are getting the carry value a and b. Next, full adder. In case of half adder, we know that it is a 2 single bit digit, but in case of full adder we can't add the carry values. So to overcome that limitation that we have to add the carry value also. To overcome that limitation, we are installing or we are implementing this full adder. Full adder is nothing but it is an arithmetic combinational logic circuit which performs the addition of 3 single bit digits. So I have written, to overcome the limitation faced in half adder, full adder are implemented. Means we are adding the carry part. So it is an arithmetic combination circuit that performs the addition of 3 single bit digits. It contains half adder, full adder has 3 inputs. In case of half adder we had 2 inputs, but in case of full adder we had 3 inputs and 2 outputs. Inputs are A, B and C in, that is carry input, and outputs are sum and C out, means carry output. So this is a truth table of full adder. In case of full adder, we have 3 combination circuits, so the possibilities are of 8 types. That is 0, 0 is equal to 0. We are getting 0. So now this is 0 plus 0 is equal to 0. So there is no carry. So the sum will be 0 and the carry will be 0. In case of 0 plus 0 is equal to 0 and the 0 plus 1, the sum will be 1, but there is no carry, we are not taking any carry, so the carry will be 0. In case of 0 and 1 we are getting 1, and 1 plus 0 is equal to 1, the sum will be 1, but we are not taking any carry, so the carry will be 0. In case of 0 plus 1 we are getting the answer 1, and 1 plus 1, that is 2, and as we have told, 2 is equal to the binary form of 2 is 1 0. So we are giving the carry as 1 and the sum as 0. In case of 1 plus 0, that is 1, and 1 plus 0 is equal to, we are getting the answer 1. So but there is no carry, so the carry is 0 and the sum is 1. In case of this also, 0 plus 0 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, means 1 will be in carry part and sum will be 0. So this also 1 plus 1 is equal to 2. 2 means the carry will be 1 and the sum will be 0. In case of 1 plus 1 is equal to 2. Okay. In case of, we are getting 1 plus 1 plus 1. Suppose 1 plus 1 plus 1. So the answer will be 3, and the binary form of 3 is 1 and 1. So in that case we are getting carry as 1 and the sum is also 1. Now the K-map for sum and carry. In case of sum, this is 0, 1, 2, 3, 4, 5, 6, 7. In case of K-map of sum, we are getting the sum 1, means the higher value. So, okay, sum, we are placing, this is 0, 1, 2, 3, 4, 5, 6, 7. So one as sum, one as we are putting one in one place, next in second place, next in fourth place, and next in seventh place. But here the ones we cannot we can't give we can't unite these ones, where we can't connect these ones. So the ones are in diagonally arranged. These ones are in a diagonal arranged method. So we are getting the answer as A XOR B XOR C in. Okay. For C in means carry part, we are giving ones are in 3, then 5. We are getting the one as 5, next 6 and 7. But in case of this, we can unite this to 1. We can take this to 1 and we can get this to 1. So after that, from that this to 1, when we are uniting this two, we are getting the answer as A B dash C in. Next for this, we are getting the answer as A B C in. Here the answer we are getting A C in. Okay, A C in. Next, for this part, we are getting A dash B C in. And for this one, we are getting A B C in. And we are getting the answer as B C in. Okay, so we are getting the answer as B C in. Next, for this two, we are getting A B C in, and next A B C dash in. So here we are getting the answer as A and B. So we are getting the answer as A and B. So for the carry output, we are getting AB plus BC in plus AC in. Next, here this is a full adder. Okay, so I have told you 3 single bit digits. So we are getting 3 inputs and A, B and C in, and 2 outputs are sum and carry out. Here there is a diagram for that. In previous case we got A, C in. So the diagram will be like this. We got AB, next BC in and AC in for the carry. So the diagram will be, we can draw this diagram like this. This is for A XOR B. A, B and C. This is A XOR B for the sum part. And for the carry part, AB means A, B. We are connecting this by means of AND gate. Next, AC in, BC in, that is B, C in. Next, AC in, that is A, C in. We can draw this by, we are connecting this by means of OR gate, and this is carry out. Okay. Next I will start half subtractor. Subtractor means, adder means this is addition of a bit or a digit, and subtractor means the subtraction of a bit or a digit. Subtractor are of 2 types, that is half subtractor and full subtractor. So half subtractor, it is also an arithmetic combination circuit that performs the subtraction of 2 single bit digits. So in half subtractor, it is a combination circuit that performs the subtraction of 2 single bit. Half subtractor has 2 inputs and 2 outputs. It gives 2 inputs and 2 outputs. It produces the difference between the 2 binary bits as the input, and also produces an output, that is borrow, To indicate if a 1 has been borrowed in the subtraction, A is called the minute bit and B is called the subtract bit. Okay, this is a half subtractor. We are getting two inputs and two outputs, that is difference and borrow. In case of adder, half adder, we got the two inputs and two outputs, that is outputs are sum and carry, but in case of subtractor we are getting difference and borrow. So as we told that first one is minuting and second one is subtracting. We are subtracting 0 plus minus 0. We are getting the answer as 0. So there is no borrow. So the borrow 0 and difference will be 0. In case of 0 and 1, we are getting the answer as 1. Now I will give an example. Suppose we are taking 2, 5 and minus 9. Okay, so here when we are subtracting this 9 and 5, this 9 is greater than 5, so we can't subtract like this. So we are taking one borrow from 2 and we are making this 5 as we are increasing this bit and we are making this as 15. So now we can subtract 15 minus 9 is equal to 6. So we are getting 6. And as we have borrowed from this 2, so we are deducting and we are getting 1. So the answer will be 1, means 16. 25 minus 9 is equal to 16. So here the giving the output 0 and 0, we are getting the output as 0, means the difference is 0 and the borrow is also 0. In case of 0 and 1, as 0 is smaller than 1, so we are getting difference as 1 and but we are taking borrow, so we have borrow will also be 1. In case of 1 and 0, 1 is greater than 0, so there will be no borrow, so the borrow will be 0 and difference will be 1. In case of 1 and 1, there is no borrow as usual and difference will be 0. So output in case of difference, in case of 1, we are putting 1 in one place and in the second place. So we can't unite these two ones. These ones are in diagonally arranged method. So we are getting this answer as A or B. So the difference for the half adder is A or B. Now for the borrow part, we are getting 1 is in the 1th place. So we are taking, we can't unite, there is no 1. So we are getting this answer as A dash B. A dash B. Now this diagram, circuit diagram for this, we got A or B and A dash B. A or B and A dash B. So here this is XOR gate. A XOR B, we are getting the difference, and A dash B, we are by means of NOT gate, we A dash, this is A dash, and now B, by means of AND gate, we are getting the borrow output. Next we can't subtract the 3 single bit digits. So for the in case of half adder, so we are implementing full subtractor to subtract the 3 single bit digit. So the half subtractor, as I told you, the half subtractor is used to subtract only the 2 numbers. To overcome this problem, we are implementing this full subtractor. Okay, so full subtractor is mainly an arithmetic combination circuit that performs the subtraction of 3 single bit digit. So the full subtractor is used to subtract the 3 single bit digit. Here the full subtractor has outputs are of we are getting giving 3 inputs and we are getting 2 outputs. 3 inputs means A, B and borrow in, and outputs are difference and borrow. So this is a full subtractor circuit. Here we are getting the input A, B and B in, that is borrow in, and we are getting the output as difference and borrow out. Next, the truth table for the full subtractor, that is where in case of 0 and 0 we are getting 0. So now this 0 will be the minutant and this 0 will be the subtracting. So from this 0 plus 0 is equal 0 minus 0 is equal to 0, and 0 minus 0 is equal to 0. So there will be no borrow. So the answer will difference will be 0 and borrow will also be 0. Now in case of 0 minus 0 is equal to 0 and 0 minus 1 means this 0 is less than 1. So the borrow will be 1 and the difference will also be 1. We are taking borrow from 1 because this 0 is smaller than 1. So in case of this 0 1, the difference will be 1 and there is borrow, means borrow will also be 1, and 1 minus 0 is equal to 1, that is 1 will be the difference and borrow will be 1. Now in case of 0 and 1, we are getting the answer as 1 and the borrow will be 1, and 1 minus 1 is equal to 0. We are getting difference as 0 and the borrow as 1. In case of 1 minus 0, we are getting the difference as 1, but there is no borrow because 1 is larger than greater than 0. So 1 minus 0, that is borrow will be 0 and the difference will be 1. Now in case of 1 0, so the answer will be 1. In 1 0, the answer will be 1 and the borrow will be, and here 1 minus 1 is equal to 0. So the borrow, there is no borrow, so borrow will be 0 and the difference will be 0. Now 0 minus 0 is equal 0 minus 1 is equal 1 minus 1 is equal to 0. So this is the 0 minus 0 is equal to 0. So the difference will be 0 and the borrow will also be 0. So next 1 minus 1 is equal to 0 and 0, as 0 is less than 1. So 0 minus 1, the borrow will be 1 and the difference will be 1. Now I am drawing the K map. Okay, in case of difference, we are getting 1 in the 1th place, 2 next 4th place. Okay, next 4th place, and this is 7th place. That is, we are giving 1 in the 1st place, next in the 2nd place, next in the 4th place, and next in the 7th place. But we can't unite these ones. Okay, we can't unite this one, so we are getting the answer as we can't unite this 2 1. We can't unite. So these ones are in single, but they are in diagonally method. So as the ones are placed in diagonally form, so the result will be A XOR B XOR B in, means borrow in. But now in case of borrow, the ones will be in place of 1, next in place of 2, next in place of 3, next one is in place of 7th place. Now we can unite this one, we can unite this ones, and we can unite this ones. So when we are uniting this ones, we are getting the answer as A bar B in, and next A bar B in, means we are getting the answer as A bar B in. So we are getting A bar B in. Next for this one, we are getting the answer as A B in, next A bar B in, means A B in. Next for this ones, we are getting A dash A bar B in, and A dash B in. That is the answer, this result will be A bar B. The answer will be A bar B. So we are getting A bar B plus A dash B in plus A B in. Now this is the circuit diagram. We can draw the circuit diagram like this also, like A dash B, next A dash B in and B in. A dash B in plus B in. So we can draw this circuit. First A XOR B, for the difference A, we can draw this as A XOR B. This is for difference. A, B, C. This is A, B, C for the difference. A's or here we are getting the answer as A's or B's or B. Okay. So B. Next we are getting A, B in. Next this is A dash, means we are taking this as A dash B. We are connecting this by means of AND gate. Next A dash B in, that is A dash B in, by means of AND gate we are connecting. Now B in, that is B in. By means of AND gate we are connecting. By means of OR gate we are connecting this three, and we are getting result as borrow out. So next decoder. I will start decoder. Decoder mainly it has multiple inputs as well as multiple outputs. And in case of decoder, here the binary information is passed from the 2 to the power n number of inputs. Okay, the binary informations here, suppose I am giving here the combination circuit that change the binary information into 2 to the power n outputs. Means when we are giving the n inputs and we are getting output, the binary informations are going from n inputs to 2 to the power n outputs. Suppose if we give 2 inputs, then we are getting 2 to the power 2 outputs, that is 4 outputs. So decoder is mainly, it is a multiple inputs and multiple output device. In decoder, the combination circuit that change the binary information into 2 to the power n output lines, which is called decoder. The binary information is passed in form of n inputs. As I told you, if I give the n number of inputs, we will get 2 to the power n number of outputs. So the binary information is passed in the form of n input lines. The output lines define the 2n bit code for the binary information. So I am giving an example for the decoder, that is we are 2 to 4 decoder. That so in case of I have told we are giving 2 inputs and 4 outputs. We are getting 4 outputs, means 2 to the power n. We are giving 2 inputs and we are getting 2 to the power n outputs, that is 2 to the power 2 output 2, that is 4. So if there is this is a circuit, we are giving the 2 inputs A and B. Now we are getting 4 outputs, that is Y0, Y1, Y2 and Y2. So when we are getting the enable part, enable means we are giving one circuit. If the enable is equal to 0, E is equal to 0, then the enable is disable. Okay, this will be disable. If E is equal to 0, then this will be disable and disable. And for when we are giving E is equal to 1, it will be enable. Okay. It will be enable. So in inputs, when the enable is 0, we are not getting any inputs. So inputs will be cross and cross, means there is no inputs. A and B is not getting any inputs, and the output will be 0 because the inputs are cross and the enable is also 0. Means the enable is 0 means this whole circuit will be enabled. So the circuit will be 0, 0, 0, 0. There is 4 outputs, that is Y3, Y2, Y1 and Y0. Next, when the enable will be 1, we are putting inputs as 0, 0. So when the enable is 1 and the inputs are 0, 0, we are getting the inputs in the Y0 part, that is as 1, and all the inputs will be 0, 0, because the one output can work only one at a time, not the all output can work all time. one at a time. So in when the next in case of enable, when the enable is 1 and we are giving the inputs as 0 and 1, we are getting outputs in y3 will be 0, y2 will be 0, y1 there will be 1, and in y0 we are getting 0. So in case of enable 1, enable when the enable will be 1 and the A will be, we are putting the inputs as 1 and 0, we are getting outputs as 1 will be in y2 part. 1 will be in y2 part, and the every part will be, that is every outputs y3, y1 and y0 will be 0. Next, when the enable is 1 and we are giving the inputs as 1, 1, the y3 will be executed, y3 will work, and other circuits will be 0. So here there is a circuit diagram, that is we are getting this as A dash, that is A dash B dash. Okay, we are getting this as A dash B dash. Next we are getting A dash B. Next we are getting A B dash and A B for in case of enable. Now I will start encoder. Encoder is just the opposite or reverse of decoder. As I have told, the binary informations in case of decoder, the binary information pass from the n inputs to 2 to the power n number of outputs. But in case of encoder, here the 2 to the power n inputs will pass, the binary information pass from 2 to the power n inputs to n outputs. Okay. So in case of encoder, the combination circuit that changes the binary information into n output lines, means 2n inputs will go through and give the result as n output lines. Suppose we are giving 2 to the power 2 inputs. Okay, 2 to the power 2, we are getting the output as 2. There will be 2 outputs and there will be 4 inputs. When we are giving 4 inputs, we are getting output as getting 2 outputs. So here the combination circuit that change the binary information into n output lines are called the encoders. The binary information is passed in the form of 2n input lines. The output lines define the n bit code for the binary information. In simple word, the encoder performs the reverse operations of the decoder. As I told, in case of decoder, the binary information passes from n inputs to 2 to the power n outputs. But in case of encoder, here the binary information passes from 2 to the power n inputs to n outputs. So at a time, only one input line will be activated. Okay, I have told in earlier case also, only one output will be activated one at a time. Not everyone will execute one at a time. So at a time, only one input line is activated. For simplicity, the produced n bit output code is equivalent to the binary informations. Next, I am giving example for the encoder. We are giving as 4 inputs and we are getting 2 inputs, because 2 to the power n, we are giving 2 to the power n number of inputs and we are getting n number of outputs, that is 2. Okay, so here we are giving the inputs. Suppose we are giving inputs as 1 in the D0. So 1 at a time means when D0 will start to execute, everything, that is this D3, D2 and D1 will stop execution, and D0 will give the result as 0 and 0. Next, when D0, now in next step, the D0 will stop execution, but D1 will start its execution. When D1 will start its execution, every inputs will stop its execution. Means D3, D2 and D0 will stop its execution and D1 will start. When we are giving the D1 as 1, so the outputs we are getting as 0 and 1. So in case of D2, when we are giving the D2 as 1 and everything will be 0, we are getting the answer as our output as 1 and 0. Next, when we are giving D3 1 and the all part will be 0, we are getting the output as 1 and 1. As I told, when the output in previous case in decoder, when our inputs are 0 0 is cross means there are no inputs. So we are, in case of decoder, we have told when there is no inputs, we are getting the outputs as 0. So in case of encoder, it is completely different. So when the inputs are 0, we are not getting any outputs because this is disabled. Okay, this is disabled. Next, I have drawn the truth table here also. Next, by means of circuit diagram, I will explain. In case of this part, where which one and 1 will be executed, means this one will be at D, this one is in D3, and this one is plus D2. Okay, D3 and D2. And in case of this, then we are getting, suppose we are taking this as x is equal to D3 plus D2, and for y we are taking this as D1 plus D3. So by means of circuit diagram, we can draw this circuit diagram like this. Suppose D0, D1, D2, we can here we are I am drawing D0, D1, D2 and D3. So then x is equal to D3 and D2. By means of OR gate we are connecting. Now in case of y, we are getting D1 and D3. D1 and D3. By means of OR gate we are connecting. So this is x and this is y. So we are getting this results, and this circuit diagram will be like this only. Okay, thank you.